In this episode, we will be learning about Python's threading module. Python has a number of different concurrency constructs, such as threading, queues, and multiprocessing. The threading module used to be the primary way of accomplishing concurrency in Python. Not too long ago, the multiprocessing module was added to the Python suite of standard libraries. In this episode, we'll just be looking at the threading module. So let's create a new script and check it out. First of all, we'll import random, which will give us the ability to create random numbers. We'll import time, and then we'll import the threading module. In this case, we're actually going to import the thread class from the threading module. Alright, so now we just need to create a subclass of the threading module. We'll create a custom thread and base it on the threading class that we just imported. And we'll create an init, initialize our thread, and we'll give each thread its own special name. And self.name equals name. And then we want to run our thread. So we have to override the run function or method. Mount equals our random. We're going to get a random integer between 3 and 15. And then we're just going to add a sleep in here for the random amount of time that we chose. So each thread will run a different amount of time, basically. And now we just need to print out our message that says which thread is running. Alright, that seems easy enough. Now we need to create an outside function outside of our threading class that'll create our threads. Let's see, for I in range. I'm going to create 5 threads in this particular example. I'm going to name each thread something a little bit different. Thread number %s and %i plus 1. The reason I'm doing I plus 1 is that when you do a loop like this, it's going to start with a 0 and go 0 through 4. And that's kind of confusing to see thread 0. So we'll start with thread I plus 1. So we have thread 1 through 5. Alright, so let's continue. My thread equals my thread class. And then you pass it the name. And right here we're creating an instance of this particular thread. And then we want to start the thread. And you'll notice that the start method is not defined up here. That's just something that's included in the thread class that we're not actually going to be overwriting. But it's still there, so we still call it. Now we just need to run this and see if it'll work. And we just call our little function there. Make sure we spell it right. And of course we have to save it. And we'll call this something like thread test. Alright, let's see if this will work. And as you can see, I didn't spell something right. Let's try that again. Okay, it's printing, so it looks like it's working correctly. And you'll also notice that it printed out of order. This is actually normal because threads will run at whatever time they want, and they all basically get started at the same time, with maybe minor differences, because each thread gets immediately called in our code. So you just start it, and then you go and start the next thread, But because each thread slept for a different amount of time, you end up getting some that run longer than others, and that's why we end up getting different prints. So now you know how to create a set of threads. Pretty cool so far. You also want to note that if you run this script multiple times, each time you run it, the threads will get printed out in a different order. So let's just do that real quick too, so you can see what I'm talking about. So now we have thread 3 that returns the first. And then thread 2 and thread 4 both return at the same amount of time. And then the last two finish up. So as you can see, it's kind of random which ones will return the first, because as you saw before, we were using the random module to decide how long they would sleep. Now we can get on and actually create something interesting to actually do something. We're going to write a threaded downloader. Now, creating a threaded downloader class is a little bit more involved than our previous example. So I'm just going to show you some code that I wrote. Here's some code. I'll just go over each piece of it. So here we import the OS and the URL lib module. We're actually going to import the request sublibrary of the URL lib module, and then of course we import thread from threading. This is our class. It's not very big, and it's fairly similar to what we had before, except that the run is more involved. So here in the run, we open up a handle to a URL that's passed to the thread, and what this allows us to do is to open the URL, and then we extract the base name or the file name from that URL, and use that to create a file on our local computer with that same file name. And in this case, we want to open it in binary mode, and write binary mode really. And then we'll loop over the file as it's downloaded in chunks of basically 1 kilobyte. And if the chunk ends up being 0 or false, basically, it'll break out of this while loop, and we'll write the chunk. Yes. Okay, so then it'll print out the message, and down here we're going to actually have it download a bunch of IRS forms. If you're not from America, IRS is our Internal Revenue Service, and they do our taxes for us. So anyway, what this code will do is it'll download these 5 IRS forms all at the same time. Let's give it a go and see if it'll work. Go up to run module. And as before, you can see it prints in basically a random order. In this case, unusually said it downloaded in 1, 2, 3, and 4. But I bet if you run this multiple times, the order will change. So that's basically how we create a nice little downloader. Not real fancy. You really can't see what's going on as it gets downloaded, but it does work, and it works quite well. At this point, you really should be able to use threads to create your own threaded applications. Other items that you may want to go ahead and research is the threading module's other options like locking a thread, or some of Python's alternate modules that you can use for concurrency, such as the queue module or the multiprocessing module. In the meantime, happy coding, and thank you for watching.